When Concorde first took to the skies in the late 1960s, humanity believed that the future of passenger travel would now and forever be supersonic. But then the thunderclaps that accompanied flights at insane speeds put an end to this dream, proving too destructive to cities and the environment. So supersonic flights over land were completely coattailed by the 2000s. Now, 25 years later, NASA and Lockheed Martin are ready to restore hope for that new era of transportation with the X-59 Quest project, proving that supersonic can be silent. The abandonment of supersonic speed was not just an emotional reaction to a couple of hundred broken windows. It was a difficult compromise between the engineer's dream of high-speed flights and the city dweller's right to silence. However, decades of inactivity have not been in vain. We've learned to burn less fuel, calculate aerodynamics better, and more accurately control the vortices around the wings of an A-plane, and measure not only decibels, but also how people perceive sound in everyday situations. Against this background, a new idea was born. To replace the concept of silencing sonic booms at any cost, experts proposed changing the shape of the sound so that it becomes acceptable. Something like how we used to tune a radio by choosing the right frequency. Only here it was the strength of the shock wave. To understand why this became a problem for anyone, let's go back to physics. When an airplane accelerates to speeds close to the speed of sound, pressure waves accumulate around it, since the air simply does not have time to move to the sides. If at subsonic speeds these waves calmly run away ahead, then at supersonic speed the airplane catches up with its own disturbances and crushes them into a thin surface, the Mach cone. Inside this cone, the pressure increases abruptly, and then when the airplane closes the tail region of rarefaction, it drops no less sharply. For us on the ground, this looks like a cone of air, and the air perceived two steep successive drops is that very double supersonic clap. The classic approach of the past era to noise minimization was as simple as possible. They identified zones where a supersonic boom was acceptable and zones where it was not. This spared land dwellers from sudden booms in the sky, saving their nerves and thus making supersonic speeds acceptable only over water. But over the past decade, engineers have been able to predict with great precision the evolution of shock waves along the long body of aircraft, meaning they can literally be mapped out in time and space, stretching out the peaks and reducing the steepness, turning a sharp, deafening bang into something so quiet that it's simply lost in the noise of cities. Along with this, the logic of regulators has changed. If earlier restrictions were built around the very fact of the presence of sonic boom, now they look at the picture more broadly, taking into account the distribution of energy over time, psychoacoustic metrics, and of course, people's reactions. The world has become even more global, but also uneven. There are no convenient direct flights between many cities today, and transfers eat up dozens of potentially productive hours for work or leisure. This is where the supersonic segment comes to the rescue. Granted, it will not replace mainline aviation as quickly as we'd like, but it will speed up long-distance business and scientific routes many times over, will allow for the prompt delivery of work specialists and critical cargo, and will also connect remote economic centers where time is money in the most literal sense. A major shift in thinking was that engineers stopped looking solely at the engine as a key to the future of supersonic flight, and began to focus more and more on the aircraft's architecture. A long, thin nose, a neat distribution of volumes along the entire length of the fuselage, an air intake hidden on the upper side, the arrangement of the wings and empennage taking into account not only the lifting force but also the drawing of shock waves. All this is no longer a design whim, but a verified design. The second, no less important factor is to shift attention from speed records to a systematic program of flights over land, making thousands of tests and measurements on the ground, including surveys of residents. And finally, we got to the demonstration aircraft, a platform on which all calculations can be confirmed in the sky, thus convincing regulators. This difficult mission fell on the iron shoulders of the X-59 Quest, an American experimental supersonic aircraft from the X-Planes family developed by the Lockheed Skunk Works division in conjunction with NASA as part of the Low-Boom Flight Demonstrator LBFD project. Its full name, Quiet Supersonic, speaks for itself, emphasizing the main mission of the device to reduce the destructive sonic booms traditionally associated with supersonic flight. The first thing that immediately catches your eye is its gigantic nose, so huge that Concorde would be envious. It takes up about a third of the plane's overall length of 99.7 feet, forcing the pilot to lose all traditional means of observing the outside world, at least in the forward sector. However, this is the main ingredient of its silent design. The X-59 pilot sits near the middle of the plane with no forward-facing window, relying entirely on the external vision system, XVS, a NASA-developed system specifically for Quest that includes a 4K camera, flight vision camera, FVS, and synthetic vision. The system uses 4K video from external cameras combined with terrain and flight data to create a digital virtual head-up display complemented by Collins Aerospace's EV's 3600 multispectral imaging system located under the X-59's nose. Incidentally, the same company was chosen to provide the Proline Fusion cockpit avionics, which displays the boom position on the ground, and the enhanced flight vision system, EVs, which improves visibility at night and in poor weather using infrared cameras. Simply put, if the XVS is a replacement for the pilot's visibility window, then the EVs is an enhancer of that same visibility. A particular note is the F414G100 turbofan engine, a modified version of the popular General Electric engine used in the U.S. Navy's F-A-18 Super Hornet, specifically designed for the Quest. It's mounted on the top of the fuselage to provide the smoothest possible underside and to protect the aircraft from supersonic shock waves, preventing them from merging at the rear and causing a sonic boom. The engine will allow Quest to cruise at Mach 1.42 or about 937 miles per hour at 55,000 foot, while producing a low 75 effective perceived noise level EPNDB comparable NASA says to a car door slamming or thunder heard in the distance. By comparison, modern narrow-body airliners typically have certification level between 86 and 95 EPNDB. So even against that background, the X-59 with its 75 EPNDB still wins. Other parts of the aircraft upon closer inspection may also seem familiar to many attentive aviation fans. After all, the X-59 borrowed the cockpit canopy and ejection seat from its Northrop T-38 Talon counterpart. It borrowed the landing gear from the General Dynamics F-16 Fighting Falcon, and the life support system migrated to the Quest straight from the McDonnell Douglas F-15 Eagle. This was done primarily to ensure that the supersonic aircraft would not also become super expensive. Thus, the amount of the initial contract concluded by NASA with Lockheed back in 2018 for the design, construction, and delivery of this demonstrator was $247.5 million. The X-59 was originally scheduled to make its maiden flight in 2022, but plans were eventually pushed back to 2025. However, NASA and the Skunk Works did not sit idle. In 2022, they installed the F414G100 engine, displayed the demonstrator outside of the hangar for the first time in 2023, and conducted a successful engine test of the X-59 a year later. In February of 2025, another series of engine tests were completed, including a static run with full afterburner. Additionally, electromagnetic testing were conducted during the same period to ensure that all of the vehicle systems were operating smoothly in a variety of scenarios. In the spring of 2025, two NASA F-15 research aircraft flew over California's Mojave Desert to test instruments designed to measure and record the shock waves Quest will generate. The aircraft equipped with recording instruments flew at supersonic speeds in conditions identical to those the X-59 is expected to fly in. And in July of this year, NASA and Lockheed reported successful low-speed taxi tests of their supersonic demonstrator at the U.S. Air Force Plant 42 in Palmdale, California. They also marked the inexorably approaching first flight of the craft. All that remains is a penultimate stage, which consists of taxiing tests at medium and high speeds, during which NASA and Skunk Works specialists will evaluate the craft's handling at high ground speeds, as well as braking, body stability, and sense operations. Looking back at the fact that aviation history knows many X-planes, the technologies of which remain in the form of drawings, it's sincerely gratifying that the fate of the X-59 is currently different. After all, now all that separates this aircraft from the title of battering ram for its supersonic brothers in an argument in a thick dossier for the Federal Aviation Administration and the International Civil Aviation Organization is a test flight followed by a survey of citizens on the topic of whether the quietest sonic boom in the world bothers them. If regulators finally say yes, it will rewrite the rules of the game for other market participants and will finally get a chance to see worthy successors to Concorde and perhaps even try flying one of them as early as the mid-2030s. You think the X-59 will be able to pave the way for other even more ambitious supersonic vehicles? Or do we still have a couple of decades of agonizing waiting ahead of us? Share your thoughts in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.